some antiderivatives to take care of. We're going to look at trig functions. And there is no shortcut for trig functions. You basically just have to memorize the damn things. Or be very good at working backwards. Be careful here. What is the antiderivative of 3 cosines?
3 sines.
Yeah. What is the antiderivative of 3 sine?
-3 cosine.
If you look at these two answers, these two antiderivatives, aren't they the exact opposite of what you get when you differentiate? When you differentiate a sine, you get a cosine. When you find the antiderivative of a sine, you get a negative cosine. Can you see how that can confuse people since you just have to memorize both those answers? So just be careful. Now, there are not that many trig functions, so I'm not going to dwell too much on it. Change the number. What is the antiderivative of 5 secant squared? So you have to think of a function that you start with, that if you differentiated it, you get 5 secant squared. So who would you need to start with? That's the guy. Is there any way of doing that? Nope. You just memorize the damn thing. Isn't it like learning French? You just remember what the French for door is. There's no, there's no shortcut for it. So that one is an X. And the last one, well, I'll change letters because I can. What would the antiderivative of a 3 secant tan get you?
Uh, 3 secant.
Yeah. Do you know if you have a table where you have functions and their derivative? Imagine a table where you wrote down the functions here, and next to it you wrote down the derivative. Couldn't you use that table going this way to find antiderivatives? So on this side, the derivative of secant is secant tan. The antiderivative of secant tan is secant. Do you see it's like a two-way street? So that's, I don't know if that's helpful or not, but that's one way to try and memorize what the antiderivatives of essentially these 4 guys are. They're the most likely ones. There are all sorts of other ones out there, but those are the most common ones. Now I'm going to do a name change, a notation change. We are still going to find antiderivatives, but it's not going to be written in the way that it typically is. It typically would be written like this. They tell you f of x, and they ask you to find its antiderivative, capital F of x. And that is add 1 to the power, divide by the new power. But we can also give you the question like this. And for some people, that's a little, it's actually more natural. If I tell you the derivative function and I ask you to find what the original is, isn't that process finding the antiderivative? So it's the same question as up here, but you see the way that the notation is given to you is a little bit different. But that's all it is. It's just another way of asking you to find the antiderivative. So the question will say, f dashed of x equals this, find f of x. Instead of f of x equals this, find capital F of x. You see, it's the same question, it's just the notation. And so it's still the power rule. And you're finished. So why do we need this notation if this notation means the same? Well, it allows us to do this. Suppose I tell you that the second derivative of a function is this quadratic. And I would like to find out what the original function is. Now, can you see that this notation lends itself to that process, whereas this notation really wouldn't help? What do you think you get if you take the antiderivative of a second derivative? What do you get?
Derivative?
The antiderivative, yeah. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. And of course, you get your plus c, don't you? Now remember, the goal here was to find the original starting function, right? The f of x. Well, I've done the antiderivative process once, right? And I've got this guy. If you take the antiderivative of this, won't we now get the f of x that we were looking for? Okay, add 1 to the power. Divide by the new power. Add 1 to the power. Divide by the new power. Add 1 to the power. Divide by the new power. Now it gets a little bit different, but just a little. What's the antiderivative of plus c?
CX?
Correct. If it was plus 5, wouldn't we say plus 5x? If it was plus 22, we'd say plus 22x. It's plus c. C represents a constant, right? It represents an unknown number. So its antiderivative is that unknown number x. And now we have to add, because every time you do an antiderivative, you have to add what's called the arbitrary constant. I am not going to say plus c. Why do I say plus d?
C and D can be different.
Yeah. Could every time you do an arbitrary constant, could the c be 5, but the d could be 22? If you say cx plus c, in mathematics, aren't you saying that the c is the same as the other guy, right? It's 5x plus 5, or it's 10x plus 10. You're not allowing 5x plus 20, right? You're not allowing any variation between the two. So that's just a little issue. Are we comfortable then about second derivatives? Working backwards gives you first, working backwards gives you f. And the working backwards is antiderivative, antiderivative again. Theoretically then, couldn't I have a fourth derivative and just work backwards to find the original function f of x? Are we good with that? Is that, you feel comfortable about that?
So far, yes.
Good. Let's use that in an application. Suppose I have managed to find a formula for the velocity of a moving object at time t. Right? I got this formula. And I tell you that the velocity at time 0 is 5 meters per second, right? That'll come in later. I can find the position function. Isn't the velocity function the derivative of the position function? So if you find the antiderivative of velocity, aren't you finding the position function? So you see, basically, antiderivative of velocity is position. So add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. 2t add c. So if you are given a question, here is the velocity, find the position function s of t, you will interpret that as, oh, you want me to find the antiderivative. We have a little hiccup. We've got this plus c, this arbitrary constant. What do you think the job, why do you think they told us that the velocity of 0 is 5? What do you think its job is?
I think that's supposed to be the position at 0.
It is. Oh, God, sorry. Yeah, that might make the question a little bit clearer. S of 0 is 5. What do you think its job is? What's it going to allow us to find?
C.
C. So the position at 0 is 0 cubed. 4 lots of 0 squared. 2 lots of 0 plus 3. And we're told it's 5, and this is a very easy one. This makes C5. And so I now know everything that you need to know about this function. So if you only know the velocity of a moving object at any given time, and you know where it is at one location, it doesn't need to be at 0. It could be S of 1 is 42. It doesn't really matter. You'll get a C no matter what they tell you. So if you know its velocity at any given point in time and its position at one place, anywhere at all, aren't you able to create this guy? Which means you now know where that object is in space. That's kind of amazing that you only know how fast it's going at any given time, and you know where it is at one particular point in time, but that's enough information to find out where it's going to be anywhere. Let's take it one stage further. Suppose I tell you that the acceleration of an object at time t is 6t plus 8. Now, this is something you couldn't do in physics. In physics, isn't acceleration typically a fixed number? 9.8 if you're talking about gravity, but whatever it is, it's typically the moving object has a constant acceleration. Isn't that the kind of story that they stick to? Well, here's the world, really more realistic. Here's a moving object whose acceleration is different at different times, right? It changes through time. And this time I will do it correctly. The velocity at time 0 is, say, 4 meters a second. And its position at time 0 is 12 meters. Only knowing the acceleration of an object, and these two, they're sometimes called boundary conditions, we are now going to create the position function. we're now going to be able to tell you where that object is at any given point of its life. What do you get if you find the antiderivative of acceleration?
Velocity.
You get velocity. And add 1 to the power. You get that guy, right? Oh, plus a c. I'm going to cut some corners here. If you're told that the velocity at time t is 4, can you imagine that that means c is 4? I'm just doing it in my head. So we now know the full equation for velocity. There is nothing unknown now. What do you get when you find the antiderivative of velocity?
We get speed.
Yeah, well, you get position. I know it starts with an S, but it's position function. It's strange why it starts with an S. You know, I would probably call it d of t, like distance or something, but yeah, that's what it's called. Antiderivative, add 1 to the power, divide by the new power. The 4 gets you 4t, and I can call it c now because there's no contradiction here, or plus d if you feel like it. And if I use this guy, can I cut some corners and say c ends up being 12? All you need to tell me about a moving object is what its acceleration is at any given time. Right? Give me a function that models its acceleration at any given time. Tell me its velocity somewhere. Doesn't need to be 0, but just tell me it somewhere. Tell me its position. Doesn't even need to be the same place that the velocity is. Right? Tell me these two guys. With this fella and these two boundary conditions, I can now tell you where that object is going to be for its entire life. I can tell you its position function. That is an extremely powerful piece of math, which is relatively simple to do. Would you agree? It's not that hard. Well, got 2 more things to do, or 3 more things to do. I'm going to finish with some physics. Right. Let's say we have an object on the Earth. What is gravity? Because acceleration due to gravity is what we're dealing with in my story. What is the number, the metric number for gravity? Oh,
9.81 meters per second squared.
9.81, right. Well, we have gravity goes at 9.81. Okay. Positive or negative? What's gravity do? Is it an upwards thing
negative.
or is it a downwards thing? Correct. It'll be negative. Okay. Now, the velocity of an object at time 0, I'm going to call it v0. You call things in physics v0 and u0 and s0 and t0 and things like that. Are you used to that notation? And the position at time 0, I'm going to call it s0. So, gravity is that. if you find the antiderivative, you get negative 9.81 t plus c, and c is that. So the velocity is negative 9.81 t plus v naught. If you find this antiderivative, you get s of t, which is add 1 to the power, divide by the new power. So I'm just going to call it a half of 9.81. That guy is v naught t plus s naught. And if I replace this guy there's the generic position function for a moving object with acceleration a. You ever seen that guy? Just off the top of my head, I've just created a physics formula. Yeah, just tell me something. And, you know, if you take a physics formula and you integrate it, do you know the chances are you'll find another different physics formula? And that was it. Okay, time to move on to the second of the three things we're going to do today. And hang in there with me for a few moments. I think that's it. Full size, is it? Okay, that'll do. Your test on Monday is on sections 4.3 to 4.9. There's 5 sections. But we're not doing one of them. So your test on Monday is only going to have 4 questions, 1 from each of the sections we're going to use. Does anyone remember which section is not going to be in the test, and it's not going to be in the final either?
Isn't it 4.5?
Yes, it is. We are not going to do curve sketching questions. They take far too long. And anyway, any of the things that you do in the curve sketching, you do in the other sections anyway. So it's not that I won't be testing you on them. Just don't need to do them that way. So you're going to have a question on derivatives and shapes. That is intervals where it's increasing, decreasing, local max, min, concave up, concave down, points of inflection. Do you know the questions that ask you those kind of things? That's what 4.3 is. 4.4. Remember L'Hopital, the limit is x tends to 4 f dashed x over g dashed x. Right, finding limits of things. 4.7. Crossing rivers, pipelines, 2 numbers, boxes without lids, all that good stuff, right? Antiderivatives. You're finished doing them, right? That's what you got. Now, if you have got really good test grades, you do not need to turn up for test 5. You might just choose not to bother. If you've missed a test or you've done badly in a test, you really should turn up. I only count the best 4. So if you turn up and you do really badly, it won't matter because the grade won't change. But it's totally up to you. You might want to say, no, I could do that Monday. I've got some revision for finals and I want to get, I want to use that time. And that's fine. It's your decision. You will not lose any attendance points because there are no attendance points for Monday, right? After today, the attendance is over with. If you don't turn up for the final, I don't think it really matters if I don't give you an attendance point. So I'm not worried about counting that one either. So hopefully you do. So 4 questions. Our final is on Wednesday, 7 till 10. Now, do you notice how early it is? 7 till 10. Do not turn up at 9 and go, oops, because I am going to remember the following. When you are if you ever become a teacher, one of the first pieces of advice that you're given is that if you want your students to remember something, say it 3 times. So you ready? The test is at 7 till 10 on Wednesday. The test is from 7 till 10 on Wednesday. You ready for it? The test is from 7 till 10 on Wednesday. There is nobody that is here right now that's going to turn up at 9 and say, oops, because if they do, Eli, I will throw things at them. Now, I do not know how I'm going to be able to do that virtually, but I will figure a way. I will drive by your house and throw a brick through it, right? I will figure a way of doing it, right? So you lot will not do that because you will screw up my life really badly if you turn up at the wrong time.
What if
Because
we have
I've
a
got
class,
to
right?
grade these things. And I have another class. So I don't want to have to jump about between 2 Zoom meetings. It's just not going to work. So you are not going to do that. Think saving your life, right? Thinking along those terms. Now, the last thing I want to show you, and then we'll call it a day. Oh, we're well ahead of schedule. Is what do I need to get in the final to pass or to get a 3.0 or whatever, right?
I had a question about the time real quick.
So let me show. Oh, go for it. What's the question?
I have chemistry at 8. So
What is a final? On Wednesday? That's the exam week.
oh,
You
right,
shouldn't be
maybe
getting
not.
anything on the exam. Oh, don't do that. You scare the EBGBs out of me.
I also
Right.
have a question.
Okay. Yes.
Wasn't it on Tuesday? Wasn't the final supposed to be on Tuesday? Because I think that's what I read in the syllabus.
Oh, shooting space. I'm looking. Oh, I'm getting old. I'm looking at my other class. Oh, shooting space.
Can't undo this.
Eli, you deserve brownie points. Eli, you deserve really good brownie points.
Thanks, Eli. I thought I was going crazy.
Me too.
I'm not going to do it 3 times. It's Tuesday 7 till 10. Actually, if you turned up on Wednesday 7 to 10, it wouldn't actually be a big deal because it's my other calc class, so you'd be getting a different version of the final. I'll have 2 versions, one, but it might be a harder version, so you probably should turn up for your class's version, just in case.
What if we turn
Right.
up for both?
So it's on Tuesday.
It's on Tuesday and the other one's on Wednesday. If you turn up for both, I will just ignore you. That's probably
Okay.
the shortest answer. Right, now, you got a report and I will send you a new one, an updated one after you've done test 5. But let's just pretend that your score right now is 85%, right? So if you look at the email I sent, it'll tell you your score is 85, your grade is whatever it is, okay? And we want to find out what you need to do in the final to get a 2.0, 3.0, maybe even a 4.0. Before we continue with the calculation, this guy will change. You might do really well in test 5, in which case it will go up. If you really do badly in test 5, it won't change. But remember, we've a whole load of homework that has to be done. So this might move a little bit, you know, it might move up a little bit, maybe 86, 80. It won't move a lot, but it might move a little. Also, participation hasn't been added. So if in the last 2 weeks you haven't been good at turning up, this could go down a little bit because of that. But let's assume that it's 85. What you need to do first is find 85% of 700, which is what I'm going to do right now. 0.85 times 700. You will find whatever your guy is times 700. This particular one is 595 points. And I'm going to call that the raw score. Now, I'm going to set up a little table. And we'll have a 2.0. you have a 3.0, and for some of you, maybe even a 4.0 is your goal. In this column, I'm going to put the total points. This is what you need to get in total, everything added up. You need 750 to get a 2.0. You need 850 to get a 3.0. And you need 950 to get a 4.0. And this guy in the middle is what you need to get in the final. So take your raw score, subtract it from that guy. And if you were that person, you'll need to get 155 points in the final. And to remind you, the final's 8,300 points, right? So what's that, about 52%? I think you should be safe. Would you agree? I mean, it is possible to fail every exam in the world, right? But you should be pretty comfortable, right? Now, if you wanted to get a 3.0, you'll need to get, take that away from that, you'll need to get 255 points, which is about 85%, which is actually doable. But it's much harder to get a good score in a final. It's 10 weeks work. There's lots of stuff that you haven't done for ages. You might make a mistake here and there as well. But I think that is doable. That person could get a 3.0. If that person wanted to get a 4.0, what would they need? They need to get 355. It ain't happening. They're not getting a 4.0, basically. Every 10 points that you add to this score moves your grade up 0.1. So for instance, 166 in the final would get you a 2.0. A 265 in the final would get you a 3.1. Do you see how it moves up 0.1? So you can figure out what the increments are after that. So are you comfortable about what you do in the final? And I'm going to write this down. After me doing my spiel about telling you 3 times, I go and tell you the wrong day. That was not the best thing to say. But it is still 7 till 10, which probably is why I didn't recognize the fact I was looking at my other class. We know that the final is Zoom, so you'll turn up to a Zoom lesson. I have to see you, just like in the normal test. It's all in PDF form, and it looks very like the practice one, but much smaller. 10 multiple choice, 10 section 2. The multiple choice add up to 100, and the section 2 adds up to 200, so that's where your 300 comes from. I think I've asked or answered all the obvious. Is there anything that I haven't covered that you would like to know? Matthew, when's the test?
Tuesday, 7 till 10.
Yeah, Sabrina, when is the test?
Tuesday from 7 till 10.
Okay. Can I not go through the entire class and ask them individually that? Can I assume that you all know it's Tuesday and don't turn up at 9? That's true, no matter what day of the week you thought the test was. Right. Are we good, guys? Is there anything else I can help you with? Otherwise, it's hi
Question
and
in the
bye-bye.
chat.
Is it? I can't get the chat directly, so let me.
It said something about if we
go and
show up Wednesday, can we take the test without a penalty?
No, don't do that. It confuses the heck out of me. Because when you upload it into Canvas, you upload it into your classes folder, and Canvas will have a time lockout, and that would be bad news. So no, don't do that, please. is the short answer. Now, if for some other reason there is a physical reason you can't do it on the test, we may have to make an accommodation there, but I really should only do that on very exceptional circumstances. Nobody should have an overlap because the exam schedule is timed so that you never get two exams at the same time. So none of you should be saying my French exam is on at the same time. It just shouldn't be happening. Okay, I'll hang about because there may be some questions you just want to ask me personally. Bye-bye.
I did have a couple questions about the 4.3 homework.
Yes,
That-
go for it.
A few of those questions on that homework just did not like me. Like, I think we even did question 13 in class, exact same question, and it did not like
It was
the
question.
interval.
Say that
was-
again.
4.3 question 13.
Okay, what was the question? Can you tell me just the specifics of it? What was the
F of
function?
x equals the natural log of 2 plus the
Oh.
sine of x. and the
Natural log of 2
interval-
plus.
The sine of x.
But I missed a bit. Oh, that's interesting.
But the
Is
it's
that the guy?
it's natural log of parenthesis 2 plus sine x parenthesis.
Oh, okay. Is that the guy you're talking about?
Yes, in the interval 0x 2 pi.
And
it did not
so
like the intervals for concave up and concave down that I gave, even though we did those in class.
Okay. Well, I could have screwed up. So it's 1 over 2 plus sine x times the derivative of sine x, which is cosine x. Yeah, I can't see anything wrong with that. Second derivative then is going to be f dash g, take away f of g dashed over g squared. And that guy is f, and this guy is g. So you differentiate the top, you get negative sine x with a guy in the bottom. Take away this guy times the derivative of that guy. And on the bottom, got that. And that's negative 2 sine x, negative sine squared x, negative cos squared x, all over 2 plus sine x squared. These two guys give you minus 1. So it looks like I have got negative 2 sine x minus 1 over that. Does that look like what you were doing?
Yes.
Okay, so what we're looking for are critical numbers. And there are a number of different possibilities. Let's look at the undefined ones. I'm not worried about the undefined. The bottom can never be 0 because 2 sine x can't be 0. The worst you could get would be negative 1. Now is that, and that only adds up to 1. So I'm only focusing on what makes the top 0. And that becomes that guy. And that becomes that guy. And so I am looking for 2 quadrants where the sign is negative, which is in the 3rd quadrant and in the 4th quadrant. Okay, when is the sign equal to negative a half?
I think the 2 that we had was either 8 over 6 pi or 7 over 6 pi and then 2 pi. I had both.
So let me. Right. So what was the one that goes in the 3rd quadrant? What did you say?
I had both.
7 6 pi.
Yeah, it was either 8 over 6 or 7 over 6. I don't know. I had them both written down for some reason.
Well, one of them's not
Right.
right. I'm
I'm
going for
confused.
that one. Let's double check on that because that maybe that was a mistake I made. I'm trying to do 7 6 pi and it's not easy in the calculator. Okay, it's good. So here are your two answers. Boom, boom. So on our number line, we start at 0. We're going to finish at 2 pi. Half a pi is here, but I'm going to call it, half a pi is here, so I'm going to call that 3/6. Full pi, I'm just calling it 6/6. So I'm just relabeling them in terms of 6, just to make it a little bit easier to figure out where they go, right? So if you want 7/6 pi, it's here. And if you want 11/6 pi, it's way over here. So our little invisible wall is at these two. That's 11 measure. So I need some test points. So I would probably pick a half pi for here. Between here and here, I'd probably choose 3/2 pi. And for the last one, I would probably choose 2 pi. So for each one of these test points, I am going to evaluate that guy. Okay, so at a half pi, what's the sign of a half pi?
I do not have that memorized.
The sign of the half pi is 1. So -2 times
Right.
1, -2, it makes this guy negative. Okay, if you do 1.5 pi, it makes these guys positive. And if you do 2 pi, it makes it negative again. So
That's
I
where the
want
mistake
concave.
was, 'cause in my notebook, it was the opposite. It was positive, negative, positive.
Okay, so that was just when you did when I did the test points, I did them in my head and I don't know, screwed it up somewhere. So
Right, okay.
that should give you the concave up and the concave down intervals the right way around. Was it the right intervals but the wrong places?
Yep, exactly the opposite places, yeah.
Right, so that's all that went wrong. The plus minuses, I don't know if I just calculated them in my head too quickly and said it was
Yeah.
plus when I should have said it was negative.
Happens to the best of us. I also had trouble with question 17. It didn't like my intervals on that one either. But I like triple
Okay, have
checked
you
it.
got the question? Right. So
I
what's the
do.
function in 17?
F of x equals x squared minus x minus the natural log of x.
Okay, I know what's wrong with this one. The natural log of x only exists for positive values.
Okay.
You can't get the log of, well, actually, you can't even get the log of 0, so I guess that's a strict one. So if you find the first derivative, your answer looks like that.
Right.
And you want to find out critical numbers. Well, 0 is definitely a bad guy. And the other one is what makes this 0. So I'm going to call it that guy. So I can do a cross multiply. And then if I do this guy, I get x equals 1, and I get that guy. Now that guy is interesting. That guy is totally unusable because you can't use negative numbers in the log. So it means there's only one critical number. And so when you're building your first derivative, you're going to start at 0. You're going to have a guy at 1. And only one critical number. Yes, you can see there's one there. So pick a point like a half and pick another point like, I don't know, 2, or if you want to, 1.5. And then you can plug in when x is a half, that is 1, that is -1, and that is -2, so the answer is negative. And when you plug in 2, it is positive. So you can see that your interval of increasing and decreasing is just from 0 to 1 decreasing, and from 1 to infinity is increasing. And you can't use all the guys this side because the log function does not exist as a real value for anything less than 0.
That makes a lot more sense.
Right.
But definitely
And I'm pretty
that
sure that
neg-
when you do this, yeah, when you do the second derivative, you're going to have to start with 0 as well.
okay. Yeah, that makes a lot more sense. Thank you.
Okay.
Mm.
Are we good? I'm a way to set up officer now. I hope. And I'll see you there.
Works for
Skylar,
me.
well, I can do it now if it's quick. Otherwise, you can leave and come in because
Yeah,
there
I
may be
got
other
a few
people.
questions, so.
Okay, so we'll leave and we'll come in. I'm going to hopefully get to the Zoom thing